Hello everyone, welcome to Cloud War. On today's video we are going to start in a new set of series. We are going to be moving from the Azure cloud into the AWS cloud. In this case we are going to see a couple of implementations working with Kubernetes. But we are not going to be working with the standard Kubernetes services as we did in Azure. So you saw those videos, we just took a couple of applications, we created the infrastructure, we did a basic setup and we deployed those applications just to test everything. In this case, we are going to be taking a different approach in the AWS cloud provider. We are going to be creating a Kubernetes cluster, but in this case, we are going to be using something that is the Auto Mode. The Auto Mode is actually something pretty cool that AWS offers throughout the Kubernetes cluster. So what is the Auto Mode? The Auto Mode is actually going to take care of all those pieces that are usually a little bit complicated to companies to handle. It is going to take care of the elastic load balancing of your application. So that means AWS throughout the Auto Mode is going to take care of creating the elastic load balancer for your application. It's going to take care of the compute as well. So think about this scenario. Usually and sometimes companies face this particular issue. They either suffer for over provisioning, that means they pay more infrastructure that actually they are going to use, or quite the opposite, they get short in the compute side and their application starts suffering performance issues. The Auto Mode is actually going to take care of those kind of things. If your Kubernetes cluster is actually taking a heavy load from your users, the Auto Mode is going to spin up more EC2s in order to take the traffic that is coming to the cluster. And quite the opposite. When you are very low in traffic and maybe there are not too much demand from the end user, the cluster is going to scale down. So that way you will be able to save money, and also you will remove a management side from the cloud engineers, because the Auto Mode is going to take care of that heavy lifting. So now we are going to take a look into the AWS console how to create a Kubernetes cluster. But we are just going to explore that part just for a visual sake to try to understand what we need to have. In the repository that I'm going to provide with this video, you will find a Terraform script which is going to spin up for you the EKS cluster using the Auto Mode. You will have all the configuration. You only need to make a small tweak which actually give permissions to your user to be able to access the cluster. So with that, let's get started with the first part, creating the EKS cluster. Now if you go to the AWS console, you will find the EKS. This is Elastic Kubernetes Service. So let's take a look. When you create a new cluster, you will have either two options. To use a quick configuration, which is going to use the EKS Auto Mode, or work with a custom configuration. Both things actually end up on the same thing. You will be able to work with the Auto Mode, or maybe choose to have a usually handle manual cluster by yourself. In this case, we are going to be moving with a quick configuration to make a sneak peek. So the two things that you will need to provide initially will be the name of the cluster and also the version of Kubernetes that you would like to use. Keep in mind, if you want to use the Auto Mode, you have to use at least the Kubernetes version 129. If you go lower than that, you will not be able to use that version. Of course, if you are creating a new cluster, I encourage you to use the latest version that is suggested by the AWS cloud provider. Besides that, you will need to provide two things. You will need to provide an IAM role for the cluster and another one for the node. The cluster role is actually going to allow the Kubernetes control plane to manage all the infrastructure resources by itself. So it is going to be capable of creating things like interacting with different services outside the AWS console, like S3, maybe SQS, or maybe DynamoDB. It's up to you. We will have the node IAM role, and actually this is one of these that is pretty important, because this role is actually going to allow the cluster to spin up the infrastructure based on the request. Let me give you an example. If the amount of requests that the cluster is taking is going to be higher, this role is going to allow to spin up EC2s. Also, it's going to be able to spin up things like block storage in case you need a hard drive storage as well, and also to set up the elastic load balancing based on that request as well. As many other services from the cloud provider, you will need to create a VPC. The VPC is going to be that virtual private network that you will have associated to your components. You could have many components in your VPC, so you have two options. You can either use an existing VPC, or you can either use a new one. That's up to you and based on your configurations. Also, you will need to provide the subnets that you would like to attach to your Kubernetes cluster. Remember, as a good practice, it's a good idea to attach multiple subnets to your cluster, especially at least two. When you choose two different subnets, make sure that they are spin up throughout different availability zones. That way, if there is an issue with the infrastructure in one zone, your application doesn't suffer and AWS is capable to redirect the traffic to the available zone. You will be able to take a sneak peek into the configuration in here, but you will see something that is pretty important to mention as well. All the authentication mode throughout the cluster is going to be throughout the API. On the latest versions, you will need to use the API. If you go maybe into the pass onto the standard Kubernetes cluster configuration, you will have to use AWS config map on the Kubernetes side. In this case, we are going to be using the API. That means any request that you do from the console to the cluster is going to be using the API and using the authentication between AWS and also the Kubernetes cluster. We spoke a little bit about this topic during the Azure series, so we explain how the roles and everything that we give permission to our user is going to allow us to interact with the cluster. Also from here we will have a couple of basic configurations like the metric service, which is actually an add-on. An add-on in the Elastic Kubernetes Service is actually plugins, you could call it that way as well, that is going to extend your Kubernetes abilities. In this case we are going to install the metric service. But you can install things like Splunk, Datadog in case you want to enhance the monitoring too, or you can install third-party providers to interact with different types of components that might be outside of the AWS cloud provider. Now you will have a big quick summary of the networking that you are going to set up and the observability that you are going to have. So in this case you will be able to have a API audit, authentication and control manager and a scheduler too. So now let's take a look into the code. I would like to show you very quickly, not in a deep dive, the Terraform code that we are going to be using in order to spin up the cluster. So the Terraform script is actually going to give us the capacity to create the cluster. So let's take a look. For this, I provided 6 files as part of the repository. In here, you will find the main.pf, which is actually going to have the most basic configuration. It is going to have the required providers. In this case, it's going to be the AWS cloud provider. Remember that you also will need to have in your local environment the AWS CLI, and you will have to configure your console with the user that you are going to use. That is actually pretty simple, so I'm going to skip that one up. Besides that, we have the configuration that I told you about. We are going to be creating a VPC. That VPC we are going to attach it into 2 availability zones as well. So we will be creating 2 public subnets using this configuration. Additionally to that, we are going to be creating the proper route table in order to associate the public output from the internet. So we will have access to the public internet. From here, we are going to be creating the cluster role. So the cluster role, as I mentioned on the previous section, is going to have the proper permissions to create things like the block storage, access to cluster policies as well, compute policy, which is going to allow us to create the EC2, as well load balancing, and also to handle the networking infrastructure as needed. As part of the node role, you will have the other piece. The node role is going to be that part that is going to allow the compute to access external services. So we will have capabilities to get access to the cluster as well. And when we are working with the container registry for AWS, we will be able to pull images as well. Pretty similar that we have from Azure when we attach the ACR to the AKS. Now the final piece is to give access to our user. So here, this will be the only file that you will have to change. You will need to provide the ARN of your user. Just replace the proper ID and the username for your user on both of these lines. Besides that, you will be able to execute the Terraform apply. So let's make a quick summary. This is going to create a VPC. It's going to create 2 subnets with an internet gateway that is attached to it. And the Kubernetes cluster is going to be attached to that part as well. So if we go back into the browser, this is going to be a visual configuration that we are going to do. We will have the private cloud, the subnets located in 2 availability zones. We are going to have the cluster role attached to the AKS cluster as well for the node role as well. And the AKS cluster is going to have the capability to create the different nodes. It is important to mention when we are spin up the AKS cluster, we need to provide 2 basic computes. Those 2 are going to be the general purpose and the system. Those 2 node pools are going to be created by default in the Kubernetes cluster. Those two are going to allow the system to have add-ons that manage the infrastructure together. So this is going to serve as part of the compute for the cluster itself. That will be for the control plane, which, if you remember, the control plane is the one that is responsible to create the deployments, handle the infrastructure of those deployments, and also to safeguard the state that we would like to have in our Kubernetes application. In here, these are going to be the most basic ones. You can use different configuration from the EKS in the node pools. This is going to allow you to choose things like node pools with a specific configuration, like which type of compute you would like to use, what will be that configuration of that compute, and maybe some of the most basic configuration in terms of networking. Let's say an example. If you want to execute maybe a load in, let's say, machine learning or computer vision, you might require a GPU. You can create a node pool that every time an application gets registered against the node pool, actually requests a VM that has access to a GPU. So that way, those machine learning or computer vision applications will have access to the proper compute to be executed. In this case, we are going to go with the basic node pools, and those two are going to take care of managing the control plane and spin up new EC2s when it actually the applications are being deployed into the cluster, and those are taking requests. Okay, so let's interact a little bit with the EKS cluster and take a sneak peek into the AWS console. Prior to this video, I did the Terraform apply because the creation of the cluster takes usually between 15 to 25 minutes. It will depend on the region that you are choosing from and the condition that the AWS cloud is using based on the configuration. So if we go into the browser, we will see that we have our cluster already created. We are using the latest version 132, and we can go in here and start exploring a couple of things. We will see something pretty similar to the configuration that we have prior to this, like for example the OpenID Connect, pretty similar to a workload identity on Azure in order to exchange tokens between the cluster and other AWS services. When we go into the compute, this is one of the places that we would like us to take a look. We will have two computes throughout the system. These two computes are actually going to be ready to take our application. So as I mentioned previously, if our cluster starts taking a heavy load, we will see more computes in here. Now from the resource perspective, we have nothing else in here besides the metrics server. So we have two pods taking metrics on the server as well. And besides that, we have the usual configuration. Also, if we take a look, we have the nodes configuration in the Kubernetes side. So when a new application gets spin up, it's going to use the configuration for those two. The default configuration for the node pool is a C69.large, which is actually the basic configuration. As you remember, as I mentioned previously, you can choose the compute type based on the load that you would like to have, creating a node pool configuration using a YAML on the Kubernetes side. Because yes, the node pool is a configuration on the Kubernetes side, but you can specify throughout that annotation the type of compute that you would like to use. Besides that, you will have all of the things that you usually encounter in a Kubernetes cluster: networking, secrets and configuration, authentication, authorization, policy, and other extensions. So let's take a look into our code. We are going to be accessing the cluster locally. Okay, now the first thing that we need to use is to use the console in order to access the EKS cluster. If we go into the console, we will be able to interact with it using the AWS CLI and the kubectl tooling. So very similar to the Azure side, AWS provides a CLI which you can use to interact with your services. For this, you only need to get it from the official website. I'm going to drop the link into the video description and you can install it by yourself. It is actually pretty simple, so I'm going to skip the installation and also the basic configuration that you need to do. Okay, so let's get the resources locally so we can connect to the cluster. So the first thing that we will need to do is use the EKS update config. This is going to add the context to our local machine so we can use the kubectl to interact with the cluster. You need to provide two things: the region where your cluster is located and also the name of the cluster. If throughout the configuration you already specified the same region that you are going to use in here, you can skip that one. So you can be good enough with the cluster name. Okay, so besides that, we have everything in here. So let's move ahead and create the other pieces. So for that, we are going to be creating first a namespace. So at the previous demo, we have three different YAMLs: a namespace, a deployment, and a service. So as always, we are going to do the kubectl apply and specifying the name of the file to create our resources. So let's start with the namespace. So now we can create our namespace. As any other interaction with Kubernetes, this is actually pretty straightforward. Now let's create our deployment and then our services. In a moment, I will show you the YAML files and what we are applying in here. Okay, let's take a look into the development console. So for the configuration, we are actually deploying an Nginx application, which is just a basic demo, so we can explore the web capabilities. So let's take a sneak peek. So we have the AKS deployment. We are going to be using the namespace that we just created. We are going to have 3 replicas of the service in here. And for the spec of the container, we don't have nothing too overcomplicated. For the service side, it's actually the same thing. We are going to map the HTTP port directly with it, port 80. Nothing too fancy on that end. And the creation of the namespace is even straightforward. So we just created the namespace, we created the deployment and a service to expose this one up. As you can see, it's pretty simple to interact with the AKS cluster once this one is created. Let's go back into the browser for a minute and explore a little bit what we have in here. So as you can see, we already have our pods in here. So let's do a hard refresh on here. So we have our three deployment pods in here. They are ready to go. Let's take a look into the deployment as well. So we have our new deployment in here. We have 3 pods ready to take whatever traffic that we would like to take. And also we go into the cluster level, we will be able to see the namespace that we just created. Nothing too complicated. And if we go back into the deployments, we can see it's ready to go. So let's expose our service locally so we can take a sneak peek into the application. But not first go into the compute. As you can see, after we deploy our application, a new container has been created on a node pool. This compute is the general purpose. So this one is the default that I was mentioning here. This one, instead of being the one that handles the cluster compute, it is going to be the one hosting our application. So as you can see, this one was created by demand and it wasn't created at the beginning. So the system is going to take care of all of the infrastructure in our cluster to manage the state of the application. And now that we deploy a new application into the cluster, we have the general purpose, which is hosting these 3 pods that we just created. Now imagine that we have more applications and those applications are taking a huge load. If you come in here into the compute tab, you will see more EC2 being created based on the demand or the amount of applications that you have. Or if you have another type of application, like I said, as an example, a computer vision application, and that one requires a GPU, when you deploy those applications for machine learning and they get used, you will see another type of computing here, which already have a GPU attached to it. So let's take a look into the service locally to finish up the demo. Now let's do a port forwarding in order to see the application locally. In case you don't remember pretty well what is a port forwarding or you don't know what it's about, it is when you have the capability to connect an AKS cluster from your local machine or EC2 or anything similar, and you will be able to access those services locally without being exposed directly to the internet. So this is good for today's demo, but of course the best practice if you are exposing a service to the internet, it will be to use either a load balancer service which is exposed throughout a public IP or an ingress layer, for example using Nginx. For today's video, the service is going to be exposed using a port forwarding in our local environment. So our service here is actually using the port 80, so we are going to map it to the same port locally. So let's execute this one up. Okay, after a few seconds it's connected, so let's go into the browser. If we go into localhost port 8080, we will see that we can access the application. So as you can see, doing a setup for a Kubernetes cluster on AWS using the Auto Mode is pretty simple. Also, we saw how we can spin up new pods automatically based on the new applications that we create. This is a very basic demo. On the next demo, we are going to be integrating something pretty special. We are going to be using Argo CD with a public ACR that we are going to be creating as well in order to push our custom Docker images. For that demo, we are going to be using a public one, and the next one after that video, we will be using a private one. So in the next, we are going to be integrating Argo CD and also Helm in order to deploy our application into the cluster. But instead of deploying the Nginx, we are going to deploy the application that is part of the repository. Thank you for being with me today, and see you in the next video.